He's like, oh my God.
Do you have 2.9?
Wait, it's not a cow. Devil.
It's in my locker, but I'm needing to go to the play.
Gotcha. Okay. So, for those of us who are here, what questions do you have about these 4 problems, or are there any? Hopefully there's not any. Mona, did you get your homework done?
From last night or the night before.
Last night.
I didn't know the homework, but I can get it done.
Oh, you can put that on that group of desk over there. That's my lunchbox. Okay. For the most part, it looks like I think everyone got these ideas correct. One thing I do want to point out, Caroline, it looks like you used the traditional point slope, at least to start. I'm pretty sure a lot of you have seen this point slope formula in the past. Is that fair to say?
Yeah.
Yeah.
So
At some point, yes.
Yeah. The version of it that we are using is this one. And I will ask that you use this for 2 reasons. One, this is going to tie into the transformations of functions that we'll study later this year. So it is good to go ahead and practice using this equation. 2, this doesn't require you to solve the equation at all. It's already got y equals. Notice all you have to do is add y1, which is what you did.
Teachers, please excuse this interruption. You can go ahead and do your attendance. As soon as you do attendance, we need the students who are on have the red ticket, can show you their red ticket, can go to the play. Thank you.
I have a red ticket.
I don't think you do.
Leave. I should have bought
Alright,
one.
please keep your mask up.
Is it too late to go buy one?
Yes.
That is way too late.
Yes. Okay.
I'm sorry.
Yeah. So Caroline, does that make sense? Okay. So just try to go ahead and use this. That's the same formula we've been looking at. One thing I do want you to do on these is I do want you to show your distribution. Keep your work neat and clean, and make sure that you show me somehow which terms go together. You can't see it very well, but if you look closely, this is blue underline, blue underline, blue underline, showing that those 3 elements go together. These are red underlined, showing that those go together, right? So show me which elements you're combining in some way. You don't have to do it that way. Just some way to confirm that you have the correct terms. Sound good?
Mm-hmm.
All right. So let's get started. We're going to look at our objectives and probably wrap up 2.9, making my point, sometime today, and hopefully get started on 2.9 is making my point. 2.10 is form follows function. Sorry for typing that wrong. But we'll try to get to that today as well. It's a little small, I do recognize that, but Braden, can you read our first objective for us?
I can show equivalency between different equations of the same line.
So we've already started to see this, that can one line have multiple equations for it? Yeah. And so even though those equations look different, they are still effectively the same, right? So we want to notice those kinds of things, and that's what we're looking at a little bit. Donovan, can you read our second objective?
Argue point slope slip oneself on the many could create accurate algebraic representation of a line.
Okay, so we're trying to create algebraic representations, those equations of a line, and so we're using point slope and slope intercept forms to do that. Caroline, can you read our last objective for us?
I can create a graphical representation of a line given an equation and point slope.
Alright, so we don't just want to make equations or algebraic representations, we also want to make graphical representations from those equations. One thing I will remind you, first, Donovan, thank you, sir. First thing I will remind you is you can totally make tables to help you translate between equations and graphs. So So you can translate between equations and graphs, but we are trying to get comfortable going from an equation to a graph very efficiently. I believe we got to this number 6 yesterday, correct?
Yes, we did.
Yes, that's where we stopped?
I think.
I'm pretty sure it is. Because I distinctly remember McKay saying that, Mr. Kinney, I'll totally respect you and keep my mask up the whole class period. Thanks, McKay. Thank you, sir. I distinctly remember McKay writing the equation. I think everyone got this equation, that y is equal to 3 times x minus 2 minus 1. Because one of the patterns that Donovan pointed out and that we started getting comfortable with is that the x is the opposite of the way it appears, right? So if it's a positive 2, it's actually minus 2. But then the y value is exactly the way it appears. So if it's a negative 1 for the y, it's minus 1, right? And so that's how we ended up writing the equation up here for number 5. But McKay, your question was, how in the world am I supposed to check this, right?
Right.
Right.
Right? So overall, we need to remember that if we were to look at the graph, if we were to look at a table, every point on the graph, every point on the table should make that equation
True.
right? So you can make a graph by hand to do it. I personally found it easier to do a table, because what do I know my starting point is?
3.
No. My starting point?
2.
Okay.
Closer.
-1.
Mm,
-2. X.
Okay.
what is my starting
Okay, let me be serious.
point?
Okay.
Y. Minus 7.
6 would be
2 negative
2 negative 1.
Oh.
It's not 2. It's not -1. It is a point 2 comma -1.
Okay.
Imagine.
You good with that, McKay?
Imagine.
Caroline, you good with that?
Imagine it not being Y.
Okay. So the point is 2 negative 1. What is the rate of change?
3.
3. A slope of 3, meaning we are repeatedly adding by 3. Donovan, please keep your mask up. I know, mine does the same thing, and I fix it every time. So every point on this table should make my equation
True.
true. So let's check it. All right, I'm going to pick this one. So what's going to take the place of y?
What's this?
What's going to take the place of y?
4. Wait.
Oh, 5.
I'm sorry.
What is going to take the place of x?
4.
4. Now, one thing I do want to point out, Donovan, yesterday, you remember when you distributed here? What did we talk about that would have been easier? Just do the subtraction, right? Don't forget, I know that y'all are used to distributing, but you can simplify when it's just 2 numbers. So it's just 3 times 2 minus 1. So is 5 equal to 3 times 2 minus 1? Do I need to separate you two?
Wait.
Are y'all able to focus and get to work together? Okay, just show me. So what is 3 times 2 minus 1?
Oh, okay, I see how you
3
got it.
times 2 is 6, and then 5.
So 6 minus 1 is
5.
5. So is 5 equal to 5?
Yes.
Yes.
So does that point make this equation true?
Yes.
So is that equation probably correct?
Yes.
Okay. So that's where we're picking up from there. You go with that, Alan?
Yeah, I was trying to figure out how you got 3 times 2, and I'm like, oh wait, it's just 4 minus 2.
4 minus 2, yep.
And it's that.
So we're picking up here at number 7. Scion challenges you to use the pattern to write the equation of the line graph below using the point 5 comma 4. So work within your groups. Mona, can you jump in? Actually, let's have you jump up here with Braden. And so work within your groups to help each other develop a better understanding of these ideas and continue working forward, okay?
I need to check my phone.
Bless you.
Emergency, family emergency.
What?
We're thinking of it.